All right, we are live. It is right on the dot. 1 p.m. EST for me. Hello, internet. Uh, all right, we are live. It
Oh,
is right on the dot.
I'm
1
echoing
p.m.
somewhere.
EST for
Hold on.
me. Hello, internet. Uh, Somebody was repeating me. All right, the echo gone. Okay,
Yeah.
great. Hello, Internet. My name is Paul Chin Jr. I'm from Serverless Guru. This is the Serverless panel. Today, we're going to talk about the next frontier of serverless, which is databases. Before we jump right into it, I think I'm just going to go around. We got a lot of new faces this month. And I also think this is the first panel we've had for 2023. So it's really exciting to be back here in the virtual studio. And if you're just joining us and you're here live, you can throw comments in the chat wherever you're streaming at. And we've got moderators and our executive producer, Jonathan, looking after it. So feel free to jump in. Why don't we start with Gilbert? Introduce yourself real quick and tell me what your favorite database is, just the name of it.
Hey, sure. So I'm Gilbert Young. I'm a newcomer at Serverless Guru, and I'm also an AWS community builder and a user group leader. And to answer your question, I think my favorite database right now is probably DynamoDB or Amazon Neptune.
Okay, awesome. Akah, why don't you go next? Tell us a bit about yourself and your favorite DB.
Okay, thank you, Paul. So I am Akah Mandela, a software engineer that's building and developing applications for business process management systems. And coming to the question of favorite database, it's quite a little bit tricky here.
You got to pick one.
but
You're on the spot now. You just got to pick one.
You gotta pick one. It's a multiple choice. They are there. You must pick one and go with it. So for me, I will go with the oldest I've been using right up to this moment. I would say MySQL. It's a relational database.
Nice. Cyril, what's up, man?
Yeah, I'm good, Paul. So I'm Cyril Bandolo, AWS machine learning hero, working currently Serverless Guru as a serverless developer. I am also confused like Mandela. I fell in love with DynamoDB with serverless, but with the data side of me, it was MySQL. So a draw. I'll just give a draw. MySQL and DynamoDB.
You got commitment issues. It's already after Valentine's Day. You got to pick one.
I know, but I think got those issues. Maybe next year.
All right. And then for our super special guest, Renato, go ahead and introduce yourself and tell us what your favorite database is.
Hi, everyone. Thanks for having me. My name is Renato. I'm Italian. I live in Berlin. I work as a cloud architect for a company in the US. So I try to handle different things at different time. Databases. Well, I would say probably my favorite database is the one that I don't have to manage, but that's that's usually the easy answer. I'm coming as well from a background in relational database, so I would probably go again with MySQL probably as a default thing. On the cloud, I will say, well, as we're talking serverless, probably I will go with with all the limitation of Aurora Server 32, probably, but that's one that I like to play with. Probably not necessarily my favorite, but one I like to play with.
So yeah, we can get into that because when AWS says something is serverless, we have to have the little asterisks when it comes to databases,
Yep.
And that's why I'm really excited about the future of serverless being databases and go ahead and what they did for ephemeral compute. They're going to do for ephemeral persistent storage, which is hilarious if you think about it. It's kind of ironic if you think about disposable persistent storage environments, which is what we want, right? As serverless developers and serverless stackers. I guess finally, my name is Paul Chin Jr. I'm a serverless developer here at Serverless Guru. I'm an aspiring AWS villain, and hopefully they'll come up with that badge and give it to me one day.
For sure.
So, let's start off with this wonderful quote that I found that is, anything is a database if you're brave enough. Okay, and so I'm going to toss it over to Akah. If you hear somebody's using a database incorrectly, like, what does that mean to you? What does it mean to use a database incorrectly?
Okay. When they talk about incorrectly, what actually comes to my mind first will be the storage space. It's like you buying maybe 1 terabyte of a hard drive and just using maybe just 1 megabyte of it. That actually doesn't really make sense, because you already got into a lot of money you're spending on it for that storage, of which the capacity is basically of no use to you.
So over provisioning, kind of like getting something way too beefy for the task at hand. All right. So Cyril, what would you say is like a good match for a database? Because there's so many to pick from. And when you're looking to build and you go and you grab one and you like, this feels right. What does that seem like to you?
Yeah, there are really so many to pick, and generally it depends on the data and especially your access patterns. So one of the major things for me is when it's structured, like you have database, which is like having clear tables like that. Just think of relational databases like MySQL. But when you have to do with unstructured data, that's when I start thinking of DynamoDB, because for structured, I would think of how I'm going to do some join maybe this table to this table. So that's why when it has to do some complex joins, I always think of relational databases like MySQL, Postgre. And when it comes to unstructured data, DynamoDB is what I just get. That's the first thing I think of before thinking of anything else.
I do love DynamoDB a lot. I would say that it's my favorite working database because it fits so well in with the rest of the AWS serverless stack, because it has that just nice natural API, right? Once you get over the PKSK hashtag nonsense, it's really fast, and it works really well. So Renato, we know we're here to talk about databases. But could you give me kind of your definition of what a database is, right? Like this is the interview question, and being like, hello, Renato, what is a database?
The first thing that will create problem to you long term, the part that usually hard to scale in your deployment, is usually your database. So anything where you store data, as you said at the beginning, it can be anything really. I mean, the definition of a database, or as the word serverless, you can put an asterisk as well. The definition of a database can mean different things to different audience and different projects. Actually, I think one of the great advantages of the cloud is you can use 10 different technologies, 10 different databases at the same time for your project. And that's the biggest risk as well for me of the cloud, that you can over-engineer and use 10 different databases for 10 different features at the same time, because you can optimize. But of course, it depends on your team. It depends on your knowledge. It depends on the portability of your solution. It depends as well how much time you want to dedicate to. I mean, there might be a little feature that, as a simple example, you want to log something and you say, oh, well, maybe probably my MySQL database, my RDS is not the best solution. Less unstructured data. Maybe I want to do, I don't know, a JSON object, throw it to Dynamo, and then I have something else that I want to put somewhere else. But then at the end of the month, you go back to the example, okay, at the beginning is maybe I'm just using 1 megabyte of data. My database is not that big. So it was really worth to split in 4 different data structure, maybe by design, yes, by reality and cost. As well, maybe by cost, it makes sense, but is really worth your time to work with 10 different technology at the same time? Well, it's always, as usual, it depends. So I don't have an answer to your, I will probably fail the interview.
No, I think, the IT answer of it depends works every time. Every time. Gilbert, so do you think that projects will require more than one type of database? Like, should developers be using multiple types of databases since there are so many to pick from?
I think I'm gonna go back to the ideology of that. It depends on your use case. For example, like if you have like a transactional need to have like unstructured data, I would say it makes sense to go like with something like DynamoDB. But if you have structured data, something like what you would want to run like machine learning services on, then I think it makes sense for you to have that in like a MySQL database. So it all goes back to what your specific use case is and choosing the right tool to solve your problem.
Totally. In evaluating kind of what we're trying to save, we have all this different type of data. We have JSON objects, we got binary files, we have like regular blob object storage. Like we shove in S3 and we use S3 kind of like a database sometimes, and that's really cool. And I think that like what Renato was saying about the cloud, how the cloud kind of gives us this plethora of choices. And if you buy into the platform, right, and then you can put your data to get it back out where like at the pace that you need. And I think that is sort of the modern software engineer's dilemma, right? Because when we are building these giant distributed network services, not everything is super fast transactional, but not everything is also like deeply analytical. So Renato, can you tell us a bit about the different kinds of workloads that match up with different databases?
Well, I don't want to start again with it depends. It depends on the size of the project. I mean, of course, we can go back to yes, if I have a transactional workload where I need to, that probably fits very well a relational database, I can go with different managed service. I can manage myself. I can go with whatever is RDS on Amazon. I can use Aurora. I can even use, if I have really large database or really complex use cases, even third-party services hosted on the cloud. I'm thinking about PlanetScale or any solution that really scale horizontally on a more enterprise level, on a bigger size. There are 10 different options just inside the relational space. Of course, then there are as well work cases where you don't have maybe relations as we mentioned before, or where it makes a lot of sense to store data, for example, in Dynamo. One common example is, I think it's now 10 years old or whatever is, oh, you need to store your photos or your binaries on the cloud and do a database. Well, the metadata, you store them in Dynamo, and the binary, you store them on S3. Is probably part of any certification, any exam, any whatever is the standard pattern. That's common as well. Well, now, I'm sure Cyril will add on that, but all the AI as well stuff has very different use cases, very different scenario, very different database. Then it depends as well on your requirement. Do you need something that you can port outside the cloud? Do you need something that you can move to a different provider? Do you want to stay on a open source one, or at least compatible to an open source standard, or you want something? Every answer is valid. You need to know what you're doing. That's more or less the short answer.
Yeah. So I'm super ignorant about graph databases, and it's like this, like, to me, it's like this new cool thing, graph databases. Gilbert, you mentioned Neptune, I think.
Yeah,
it
did.
Do you want
I did mention Neptune.
Yeah, can you educate me and the rest of the audience on what a graph database really is all about?
Yeah, sure. It's still a bit new to me, and it's still something I'm labbing on and getting to know exactly what it works. But in my definition, I'd say a graph database, it maps relations or connections to nodes. For example, like if you have a social media application and you're trying to figure out like what's the connection between your user and the content on the social media, you could build out a graph database to show how a user relate to a specific content. If that makes sense to you guys.
Is that faster than, like, is the power in being able to pull out the relationships faster than like a SQL database?
Yeah, the advantage is that because it allows you to query connections and relations versus having it stored loosely in a SQL database.
Okay, I think I'm starting to get it. So I we've already been at it for about 15 minutes, and I think our viewers should realize like there's just so much choice now. And then Renato mentioned planet scale, and that reminded me that we need to talk about these like cloud service databases, right? Like it's not like an install on a machine that you got to do. You're not grabbing an image of was it Postgres or Oracle or something. Like you are now signing up for a cloud database with like a full company behind it. What do you all think about that? I'll start with Cyril.
Yeah, for generally the cloud, when you're on-prem, there are lots of things that could go wrong. And with the fact that when you use the cloud, like one of your, like the backend, just the fact that AWS has so many engineers who are really, really super talented, it's just so logical for you to try to push that responsibility to somebody who would, on the other side, assure the security, assure that you have that redundancy, that availability, the fact that you can access your data anytime, even when you sleep. Because on your own on-prem, you would have that there's so many things that could go wrong. But on the contrary, as soon as you push it to with thousands and thousands of engineers that cloud like Amazon has, and even all the different stages that they do before deploying any new service. I mean, it's just so crazy. I just feel safe when you push it to them.
All right, so for you, the cloud is this blanket of safety. It's a fluffy blanket wrapped around your database.
Yeah.
Akah, can you tell me a bit about the pros and cons of maybe cloud databases versus traditional, installing it yourself?
Well, when we come to this cloud computing, as somewhat even before getting into cloud and doing things traditionally, it's true, just as Cyril said, it's a lot of work to do. To carry on, you start by provisioning your servers, you have to install softwares. The worst when it comes to patches. You will need to look for some sort of a time window whereby your system has to go down for a little while you're doing certain upgrades right down in the background. And not to talk about time consuming. Let's take example, you want to spin up right now a MySQL database. Well, you need to install it, you need to have a server to run it and so on. But with the cloud, it's a matter of minutes, just in a few minutes, a few clicks, and you're up and your database is good to go in. Anyone that wants to start consuming it can consume it. Now, there's also another critical part of this. When it comes to database, we have security. Now, it has always been a long time debate when I've had discussions with other people whereby they say, but the cloud is simply someone else's PC that is hosting your software. So when you say it is that secure, what do you mean by that? How can you tell me my data is found somewhere else in somebody's data center, and you telling me that is that secure? So at times people are really skeptical when it comes to moving certain workloads to the cloud. They say, okay, yeah, the cloud is easy. If I move this, it's going to reduce me some workloads. But the question comes in, why? What is it? Is that necessary? Is it really what we want to do? Do we want to expose our data out there? Because no matter what is said, it's someone hosting your data. They may tell you it's just your contracts licensing. We don't have the right to access this. We don't have the right to access that. But well, it's someone's PC. You might feel secure when you are the one handling the stuff yourself. And well, if something goes wrong, it has gone wrong. We take all the responsibilities of it. So pretty much real-time, long-time debates. We're going to then moving back to the cloud or posting on premises. So better time to go in for the hybrid. Okay, we are going to keep on some data in-house, and then we are going to host some part in the cloud. So things like that.
Exactly. So just because it's in the cloud doesn't absolve you of, your general due diligence. You have to be able to still, retain good security policies on the databases that you're provisioning in the cloud. So, Gilbert, can you tell us about sort of your pros and cons of cloud databases?
Yeah, for sure. I'll start with the pro first, and I think it gives you the ability to scale. I know I'm pretty sure you guys have seen Silicon Valley when the guys were hosting their own server and databases in their garage, and when they had the increase in traffic and Guildford was going crazy trying to manage the database and servers. So I think one advantage is definitely gives you the ability to scale, and it's perfect for streaky workloads. And I would say a disadvantage would maybe be like even though it's in the cloud, it still has some sort of responsibility. So maybe you would need a team of like experts or engineers to solely look at solely look and monitor the databases, like making snapshots at certain point of time, etc.
Yeah, that makes sense. I will tell you my personal con for cloud databases, especially on AWS. They're like, "Yep, you can spin up anything you want." I'm like, "Great." So I click OK, and then it's like $3,000 an hour, and I misread the fine print, and that is an experience that a lot of people have. And AWS isn't incentivized to fix that. And part of my campaign for being an AWS villain is saying like these cloud databases and these services, they really, the ones that are going to do well are the ones who are going to clearly articulate how it is priced and how it is serviced, from an end user point of view. So let's throw it back to Renato. And I wanted to ask you about that sort of that experience of working solely with a cloud database when you have to give up certain ownership choices about how the data is spread out or sharded or backed up. You're more locked into the solution itself. So can you tell me about your experience, and the trade-offs of working with it? Is it just like totally worth it? Or are there still some caveats that you would have?
I actually think it's not totally worth it. I think it depends as well of the level you want to go. I mean, even inside the cloud, I can even simplify it in 4 different ways you can do it. You can use the cloud just as your infrastructure and do as you were doing your own data center. So I run my own MySQL cluster, installing on EC2 container, whatever you want, but I have full control. I'm root of that machine. I can do whatever. That's option 1. I would say it's just for very few, the very super skilled one that have very specific scenario. If you have, I don't know if you're using a fork of MySQL, I think it per corner, something else, maybe it's not that you want, that's the only option you have basically. Option 2, you go for something like RDS. It's managed. You give away some flexibility because you have no control of certain feature. You can optimize up to a point. It's already optimized for you, is 80% done. If that is good for you, the time you save, the complexity you say. I mean, if you think how popular our service like RDS for many years is because at the end, maybe running a database is not that complicated, but maybe there's a big difference between having to manage a passive node or a failover versus just click a checkbox. I mean, that's the difference. But of course, you give out some flexibility. You can go one step further. Instead of having a standard, for example, MySQL on RDS, you can go to Aurora. You get more benefits, something more tailored for the cloud, but you give up a bit more. I mean, there are things you cannot do. It's not technically anymore the open source version with a specific that you can support it, but there are some more limitations. If you think even the serverless version, that is the next version of Aurora, there you can even customize less because they choose many things for you. You cannot enable, I don't know, the event scheduler. Or the more you go towards the cloud, the more you go towards a managed service that is fully embedded in this, the more you give up. Which level do you feel more comfortable? Well, it depends on the use case. It depends as well how much you want to optimize cost-wise. Because, I mean, less to do usually means as well spending a bit more. That in most cases is fine. But there's not a simple answer. But yeah, you are giving up a lot. As long as you understand that and you are fine with that, it's great. But
that's a perfect segue into Almir's question. of whether or not you should go RDS or serverless Aurora and why. Like you were right there. You're like, so let's get into it. Like if you had to start checking off bullet points and you've got a new service that's coming up and you need a relational database, when are you going to pick, RDS or serverless Aurora right now? And like why would you pick it? You know, like what's the thing in serverless Aurora that's like amazing, the thing that in RDS that you know is going to be rock solid? That was to you, Renato.
Ah, it was for me. Sorry.
Yeah, sorry. You were already on that. You were already
Sorry
there,
about
and
that.
then Amir came in with a question.
Absolutely.
I tried to transition.
I would say it really depends on what I'm doing. Probably I will say serverless Aurora is not cheaper. Actually, it's probably more expensive. I mean, many people say, oh, I'm running my micro instance on RDS, always running, and now I'm moving my use case to Aurora, and I've realized that on the serverless version, even the minimum capacity that I have to run, because yeah, there's a minimum capacity you have to run. We can go back to that one later, but it's not really serverless in that sense. But what you're paying for is that elasticity. You're paying the ability to scale automatically for you. So if you want to go and enjoy your weekend away from the laptop, that has some value. I mean, the ability that it scales for you. So as your front end scale, your back end scales as well, your database scale. Okay, it's just scaling vertically. So it's not maximum scale, but still it might save you from downtime, might save you to intervene in the middle of the night for your new startup and your new project that has to scale. Is that the best way to optimize your cost on the cloud? Probably not. So there are many use cases where I will, and then there are use cases where I will use RDS because I have to use RDS, because maybe I'm relying on feature that I can have on RDS and I cannot have on Aurora serverless. That's So short answer is if elasticity is very important because I still don't know what the project is going to be, probably I will go with Aurora serverless. And when I have a better feeling, maybe I will switch to Aurora, more a traditional one, or change the approach later on when I can maybe even afford the database administrator.
All right. Well, as our applications like just keep getting bigger and bigger and bigger, and business always wants more and more metrics and more analytics and more big data. Cyril, can you tell us about like what it means to have databases for analytics and like quote big data like Redshift or BigQuery on GCP? What makes it like a big data database for analytics?
Yeah, sure. Because the first thing you need to understand about big data is the fact that it's big. You know, it's no longer it's no longer a game. We're no longer playing here. It's real data. So it's in petabytes. So most of the traditional databases were not prepared for that. So that's why you would see they will be better suited for distributed kind of databases where you can use some distributed computing, like EMR serverless, for example, would be good in that situation, just for the fact that it can be able to use lots of nodes and masters and be able to distribute that workload, because big data, there's lots of processing that has to be done back and forth for you to get maybe those predictions out, because you have to deal with lots and lots of data, like ChatGPT, for example, lots and lots of data to come up with inference. So you only need to do that on a cluster like EMR serverless, or like you said, the Aurora. Yeah, but then you can't just, on a traditional database, has its limit. Yeah.
Let's go into that a little bit more, because I feel like growing machine learning data sets are going to be part of our very near future. Like, I think everybody's going to start looking around being like, which of these bits can we keep and feed back to the machine? So tell me, Cyril, about what's it like to build out a service that is meant for machine learning and the database that has to go with it, and like the kinds of considerations that an engineer will have to choose in making sure that they're getting the right features out of it?
Yeah, sure. So that's the first thing is because it's like in the pipeline, the first thing is about the volume of data that will be coming in, because most of us, when we start learning, I'll talk about the AWS cloud because I'm more used to that. So when we start learning maybe AWS, machine learning on AWS, the first thing we come across is SageMaker, which is like a very powerful service. Very, 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 I mean, it's a Swiss knife for machine learning, but then it has its limits, because when the data is really big, SageMaker can't help you. That's when you need to look for something that can do the processing in memory, because the problem is being able to transferring the data, transferring out, treating it before sending it back. So you want to go and treat the data in memory, and that's why things like Spark come to mind. And then Spark has its own machine learning libraries. So you will need to trade off. Maybe on SageMaker, you had 80 interesting libraries you could pick from. But now, because this is big data, you just go to Spark and maybe you can just choose out of the 5 possible options that are available for you there. And there's nothing fancy you can do more than that, because your problem is no longer the prediction, but your problem is, how do I handle this data with large velocity, volume, veracity, all the V's? So that's your biggest problem, not the prediction. You just pick whatever is there, do your light predictions, and then you come out of it or reduce it in batches and send to SageMaker. So the key is that pipeline is the volume of data coming, but there are lots of things that come into place. But then just to show you, SageMaker has its limit, and at times you might need to depend on a cluster like EMR or Spark.
I see. And once you get to the idea of a cluster, like it's getting much more complicated for operations at that point, right? Like we're no longer talking about clicking around in the console, right?
Yeah, sure. You're not talking about some Spark code, yeah.
Okay.
Exactly.
So let's continue on with big data. I'll open it up. Does anybody else have something they want to chime in on about getting their services ready for massive analytics or machine learning inferences? Just open it up.
Yeah, we can go in with because at times also depends on the pipeline through which the data is coming in. So we can have services whereby they're capturing data just in the form of images, or a mix of both structured and also unstructured data. So that becomes at least a volume. Once you identify that, okay, yeah, I have this device, it could be a sensor, which is coming in with both structured and unstructured data. It already permits you to know where to send that data, to which database. There you can make a use of mixed database, both for relational and non-relational data that comes in. So something like that.
Okay, so in your pipeline, again, we're gonna be using multiple databases, more than likely, because one can't just do it all, and that's a realization that we can have. Renato, were you gonna chime in?
Yeah, I mean, that's one thing that we tend to usually hide a bit, that is a bit sometimes the elephant in the room, is the data transfer aspect. That we tend to do great design. You see amazing sometimes boards where someone show you 5 different services with petabyte of data going around, analyzing 3 different cloud providers and whatever else. And the first reaction I have is that data is transferring out as an egress fee from one service to the other one. So in certain scenarios, those data transfer costs are going to be the biggest part of your bill. So part of the design, and usually something that comes too late in the design phase. We tend to focus too much in where we store the data, how we process the data, a bit less in how we transfer data around, or if we really need to transfer that data around, or if we have better way that maybe we first process it and then transfer it to whatever it is. The fact that on the cloud you can transfer terabyte of data in a few seconds doesn't mean that you should do it. You can, but Amazon is happy, Google Cloud is happy, but probably you should think a second before doing it.
Yeah, exactly. That reminds me of this hilarious hack that I saw where if you take any file and you chunk it up into bits and you re-encode those bits as pixels and RGB channels, and then you smash it all together, you can upload it to YouTube. And then you can use YouTube as a database for your binaries. And all you got to do is call it and then download it and then reverse it. But this may be against terms of service, but you could technically encode all of your data, send it up to YouTube, and YouTube will archive it for you as just like random noise to us, right? And I think that's the kind of creativity and the kind of like cool nonsense that we can do. Y'all are familiar with like Corey Quinn when he wanted to make Route 53 a database? And that was like just like the most amazing moment for me. I was like, oh yeah, because like Excel's a database. You know, I'm sure there's lots of companies out there that are running real numbers on just like giant Excel spreadsheets.
That also adds to what I was gonna say too. Like I think a recent pattern I've seen is people incorporating AWS step functions in their data pipeline. For example, like when you're trying to pull data from more than one place and do some sort of processing and map it onto a table or wherever you have your data lake or data warehouse. So I think step functions is a great way to get data into your pipeline as well.
It does make me think, like, our solutions like Notion and Airtable and Google Sheets and Excel, are they serverless databases? Right? Like, you didn't have to provision anything for Airtable or Notion. You just sort of like write a cell and it's there and you can call it. Yeah, let's talk about it. Like, is that a serverless database?
Well, let's first say what a serverless database is, because you could extend even if you just think about the standard cloud provider. If you think about AWS, there are many services that are technically serverless that have been there for years and no one ever called them. I mean, SQS, if they had to release SQS today, they will call it serverless. That's how they will probably do it. And as well, the pricing model is a serverless one. So that's even S3 for a wider definition of serverless, you could call it serverless. It depends how you stress the concept of serverless. What do you mean by serverless for data? If you just mean a pricing point that basically you pay for what you use and is made redundant, so you don't have to think about point of failure yourself. Well, yes, in that definition, anything that is hosted by someone else that make it redundant and make it transparent to you when one server goes down and that you just pay for what you use, well, I will find hard to argue with you that it's not. But
there we go. So yeah, I'm proudly gonna announce, I think, with the professional endorsement of Renato to say that my Notion workspace is a serverless database. Like, let's go.
Yeah, this brings me also to the AWS Honeycode, which actually you're building application in the low code form. But if you want to look at the database behind, it's some like Excel. It's actually Excel-like database that is being run on top. So
yeah, I mean, Excel, PowerPoint, they're all Turing complete. You know, you can do it. You can do it. Gilbert, can you tell me about what you think a like serverless database would feel like your perfect serverless database?
Good question. I think it has to be a pay-as-you-go service, and also the least configuration on my end that I got to do to set up data, and also it has to have something in there that like just clicks, whereby I could like click a button and it does like snapshots and all that stuff for me. So as long as it has something for me to do with least configuration and it's cheap and it's pay as you go, I would consider it a serverless database.
Okay, so we got cheap, we got easy, Yeah, cheap and easy. That's the way to go for serverless. I like it. Akah, what do you think your like perfect serverless database would feel like?
Now, to me, if there's a way whereby I can take this management of infrastructure away from me, but yet I still can keep my data, that is, it's some sort of complicated. But if you can take that infrastructure, but I want my data to actually remain with me while you manage that infrastructure, it's just like, okay, I give you the machine and I take the hard drive.
Mm-hmm. You know, that's not a bad like analogy, right? Like if we were able to create an interface where we knew like the stored bits are under our control, but all of the routing and the networking and the machinations, the partitioning of all of that was like taken care of by somebody else.
Yeah.
Again, I think Notion serverless database is coming up as a winner. So I just wanted to say that Samantha in the chat said that she's definitely hearing the lesson that databases depend on workloads. Like it depends. She's an IT professional now, or they are an IT professional now. If you can say it depends and then follow it up, that's it. That's all we got. So Cyril, I think what we're also headed towards is, the low code integration for developers and end users to interact with these databases. Can you tell me a bit about some maybe some low code platforms or solutions that you've seen to interact with different databases that you like?
Okay. Honestly, maybe this question would have gone to somebody else, but I'm this kind of, you take away that vibe of that developer vibe from me, then it's no longer the thing. So because I have made it an effort to avoid low code as much as possible. I don't even look at it. Anything saying low code, I don't even look at it. Maybe this year I would.
You're
Maybe
missing
this
out.
year I would. Maybe this year I would, but then the vibe, please don't kill my vibe. But maybe this year I'll change. I'll pass that question.
Whenever I get a chance, whenever I can like host my own chat GPT without feeding into the mega model all my private information, like I just want to be able to look over at a floating ball and just say like, hey, I got a user, save them, and like that's it. Like that would be perfect for me if I could just tell the floating sphere, like I got users and every user has a car, figure it out. Like that's great. I'm all about some low code.
I was gonna add on what Cyril said. I also feel the same way as Cyril, because my experiences with low code tools is that it makes it so easy that it's complicated, because you can't actually manage what's going on under the hood. And if you want to tweak something, there's no way to get it done. So I'm all for writing my code. That's what makes us an engineer.
Renato, what do you think about low code databases? You're muted.
You don't want to say that I was never gonna say that I'm then the only one that say I'm lazy. I'm the lazy one. I'm gonna use low code. So no, I'm an engineer. I'm not gonna use any low code solution. No, no, jokes apart. I think again it depends on your use case. As it's a bit, I see it as a bit in the database world as well. Is we say before, you want to give away some flexibility in exchange of simplicity. So yes, I want that you manage my database. I want that you do everything for my database. But well, then as you manage it for me, most likely I cannot touch everything, because as in I don't want that people touch my laptop and change the configuration of my laptop. Any provider is not going to let you change everything, because they take the responsibility at least of a part of it. So it depends where you are in your journey. I don't see a solution that fits all the scenario that they're going to take over the world with local solution, or even with serverless databases the same. it's not going to fit every use case. If you have a large database that with terabyte of data on every partition, probably you're not going to use Aurora Serverless. You have your own team that knows how to manage that cluster. You always said it. The same with code. If I'm building my very simple prototype for a little app that I want to test, maybe I go with a quick solution where I don't want to look under the hood too much. If I'm building something long-term, I have a different approach. That's
very fair, very fair. Well, I will definitely say I'm the laziest programmer I know, because I don't want to type anything. Because every time I type something, it turns out to be wrong. I don't know how that always happens, but the less I type, the better my programs seem to work. But that's just me. That's just me.
You're definitely not the laziest. Because like when it comes like to DynamoDB, you have the AWS NoSQL Workbench, which is actually pretty good to interact with DynamoDB. It even gives you the possibility of generating codes for Java, for Node.js, and then you just look at the code, maybe you tweak it into your own way or how you want it to behave. And no, for me, low code is really pretty cool. I've had the possibility of using Microsoft Power Platform, which is also a low code environment, to build applications faster and push them to production. It's good, but just as Renato says, it's not going to suit all the use cases. So, well, you are definitely not just the laziest one, Paul. I am with you.
What I've learned about databases is that it's sort of like, for my use cases, what I do is a lot of like REST API CRUD stuff, right? Like, honestly, day in, day out, it's like, go get this thing. It's an object, give it back to me. And like, for that, I am really hankering for like just a really nice, easy, like key value, no problem, just like connect to it, shove a key and value in there, and then ask for it back again. I think that there's a ton of like, I'm surprised, like some of these other like Netlify and Vercel, they'll come out with some like Redis open sourcey type thing that developers can use just for quick key value, like caching and stuff like that. That's what I'm looking forward to, more of those kinds of solutions. And then I just wanted to finish it up with probably the most difficult, well, one of the most difficult things in databases. You've already got one. What do you do when you want to make it shiny again? Like you've already got data that's making you money. Like you're not going to be able to get rid of it. Like, but you got to build new services, and your new services are kind of out requesting what your current stuff can do. What do you do? Let's start with Gilbert.
Hey, sorry, can you repeat the last part of the question?
Yeah. You've already got a database. You can't get rid of it, but it's not handling the number of requests that you need, and you've got more services coming on. What do you do?
Good question. I would say I would start to look at couple queries and see how I could optimize the queries, and also look at the data that's stored and see if you could maybe, are you storing the data you actually need, or are you or if you're storing data you actually need, if you can get rid of some. If not, look at the queries and optimize them to receive better performance.
Okay, optimizing what we got. Okay, Cyril, what do you got? What's your solution?
Yeah, just similar to that, because, for example, if you take a tool like the Kinesis Data Analytics, it would help you to on the fly be able to like put some filters to say, okay, maybe this goes out, this is coming in. So if you don't need all that data, you could try to filter it out so that just the important ones stay, and the ones that you don't need go maybe to another bucket, a strip somewhere, just like stored there. But you like create two routes. If you meet this condition or this criteria, you pass. If you don't meet this criteria, you go this way. So it's still in optimizing your queries. And then there might be some services like the DynamoDB Accelerator. So there might be some additional things you could do. So it just depends it just depends again on it just depends again on the database at hand. You might just need to monitor your logs, see what you can improve on in terms of what the service, the cloud also is providing for that service, and then see how to implement that, or add another service, chain it, like the Kinesis data analytics to filter for you, so that before it gets to your database, it's like, it's slow down or things like that, or in batch, or something like that.
Okay.
Just depends again.
Spoken like a true data scientist. Pre-process, like do the heavy lifting up front. Akah, what do you think? How would you answer this?
Yeah, for me, I think we are going to go with a more of a hybrid approach, because at times it's really, really difficult for you to start thinking of throwing away the current one because it actually doesn't adapt to your new needs. But rather, we should go in for what is that services that, first of all, takes into consideration what I have, and then add other functionalities to it to adapt now to the new things I am about to add in there. So I take it and we move it like that. I see a service and I know my own, what I currently have can run on the cloud in this particular services. And in addition to that, I can have other extra services that come through it. So, yeah.
Very cool. I like that. We're very resourceful answers, kind of like dig deep of what you got first before you go and add something shiny. I like that. Renato, what do you think, man?
I think I second what has just been said, in the sense that if you might be in two scenarios. One, you want to build something new in terms of functionality. The other one is you are struggling because, well, your database is now your bottleneck. Well, in the cloud, you have the big advantage that you have some form of elasticity. Even if you just start with CPU memory, you can. Vertical scaling is not elegant. It's not the solution to every problem, but you might gain time. Yes, you're going to spend more, but you gain the time to fix your problem. If your database cannot handle the new load, well, yes, then I will fix the queries, then I will change maybe my schema or whatever, but I gain the time to do it. If it's a problem of write capacity, so IOPS or whatever, takes a bit more time, but because it's not a milliseconds, seconds, or minutes change, it takes maybe hours, but you can still do it and gain time. Mm-hmm. If you want to build something new, you might experiment and you might fork to different database, you might integrate something else. In the cloud, you can easily do it. Always thinking that it's easy to get out and spread in 3 different technology, or even just 3 different databases, because you can. Much harder to go back, in the sense that, yes, I can get some data out of my Dynamo and move it to somewhere else, or some data out of my RDS and say, now I'm doing that on Dynamo. But then if at some point you realize it was not the best choice, yeah, you can still migrate back. There are nice tools, nice services as well that let you migrate data, but requires much more effort than initially planned. So I will always try to first understand if it's a long-term thing I need, or if it's just a re-engineering, or if I'm just suffering due to a particular problem. It can be even a regression bug that someone introduced in my code. Well, then maybe I will just scale up, spend a few dollars while we fix the problem, then go back. That's one of the not shiny, but things that the cloud can offer you compared to do it at home, where when you run out of your rack, you're running out of your rack.
Yeah, I can only imagine like the days of like we're out of computer. Like like I have to go get another one and plug it in. Like we are out of computer. And I'm very thankful I don't have to deal with that on a day-to-day basis. Like we've gotten the fundamentals of distributed applications to where, you know, for the most part, like our cloud services can keep up with the things that we need them to do. You know, there's not a whole lot of scenarios where I think if you go to reach for, you know, a current generation solution, that it's going to run out on you. You're going to find some other kind of throughput problem before it doesn't scale enough. Well, you run out of money or something. Like that's the idea in the cloud. All right, cool. Well, I want to see if anybody's got any questions in the chat. It looks like we don't. So let's go ahead and wrap it up. Everybody, thank you so much for coming. this week to the serverless panel on databases. I'm going to give each of our guests one last chance to give a shout out for something they're working on, things that they're doing, things that you should check out. Renato, you're our special guest. You go first. What's good?
I think the one thing we didn't mention is that the cool part for me of using the cloud and all those so-called serverless databases, yeah, you need to be careful about not spending €3,000 just because or $3,000 because you just turned on something. Just put your things in place and make sure. But you can experiment. You can go and create a database now and have a database run. You want to try your first, I don't know, Dynamo, you want to, for the first time in your life, run a Postgres or whatever. There were some constraints before. You had to be able to install it, and it will take it now to even just experiment, do something with a serverless database. It's just, you create it, 2 clicks, it's there. Maybe it's not 100% configured as you want, but it's there available for you. So, and you can throw it away after half an hour. So just go there and take advantage of that. Play with all those technologies.
With it, time to market. And what is Cloudiamo?
It's just a blog where I collect all my. I love to play with the cloud, really. I mean, I love to test things in the most, I would call it, simple way as well. Like, it's not that I don't trust load testing. I mean, there are very cool guys out there to stress, for example, the database show you the best. But I love to try simple use cases and try them on different servers, database, different technology, and see, can I, for example, see how elastic is the service, how much the service costs, and do it in the most basic way. So that's what I use that website for.
All right, great. Well, definitely everybody should go check it out and watch Renato kick the tires on your favorite database and see what he thinks. All right, Gilbert, final words.
Yeah, I'll just add to what Renato said that I think everyone should take into consideration of like the cloud is basically like a playground or a sandbox for you, and you should take advantage of it and keep loving in your free time, because that's the only way you'll get better, and the only way it's actually like practicing before your time actually comes to produce. So just keep building small projects, and at some point it all sums up to having like a great tool or a great understanding of how everything actually works.
Akah.
Yeah. All I will add is that you should not limit yourself to just one cloud service provider. That is, play a little bit with A, play also with B, and play also with C and D. There you have a wider scope of comparison between all of them.
Experimentation is key in this industry for sure. Cyril, hit me.
Yeah. So I would say it's easy to just leave it like an idea, or I think I'm going to do that, but the best time was yesterday. So it should be that bias to action, because the cloud is more, let's go practical. I mean, we need to get hands-on. We can't just think about the cloud, read about it, or take certifications about it, and we are good. You must get those, you must get your hands dirty. So we should really have that bias to action. Go on, log in, turn on that service, look at all that all the possibilities. I mean, all that you can do. Maybe there's a provision, there's an on-demand. Just read, look at what is available. Try to get into it. Otherwise, we will just be watching videos, listening, getting motivation, but no action. So it's time to go to work, and let's build, measure, learn.
Let's go. That's a wonderful way to end, definitely. So thank you all so much for being here. If you're catching this in the future, but you're watching it now, hit the like, subscribe, smash that share, hit all the thumbs up, and we'll see you on the next one. Thanks.